In the previous module, you connected and named all the external devices needed for the pick and place application. But before you can start programming the robot, you have to configure the gripper. In this module, you will learn how. For the robot to work optimally, it needs specific information on the attached end effector. It needs to know the position of the tool center point and the end effector's center of gravity. These values are defined as the distance from the center of the tool flange to the position of the point. Finally, the robot needs to know the payload, which is the weight of the end effector. We'll start by determining and configuring the tool center point. The tool center point, or TCP, can be found by finding the points of contact between the tool and the workpiece. The TCP is located in the center between the points of contact. Let's do a few exercises to train you in finding the TCP. Where's the TCP on this gripper? That's not it. Here's a hint. The points of contact are here. Try again. That's right. The TCP is in the center between the points of contact. Where is the TCP on this vacuum gripper? That's right. The TCP is in the center between the points of contact. Where's the TCP on this glue dispenser? That's right. The only point of contact is the end of the nozzle. This is also the TCP. Now you know how to find the TCP. The next step is to configure it in the software. The robot needs to know the position of the TCP relative to the tool flange. This is done by entering up to 3 position coordinates, X, Y, and Z. Let's configure the TCP for this gripper. To configure the TCP, start by clicking the Installation button in the top ribbon. Then click the TCP button in the left menu. Here, you enter the position coordinates of the TCP you want to configure. When the TCP is located directly on the Z-axis, like here, and not offset on the X and Y axes, the easiest way is to just measure the distance from the tool flange to the TCP. Now, grab the ruler and measure the distance from the TCP to the tool flange. Afterwards, click the Teach pendant icon. Enter the distance in millimeters in the Z field. That's not correct. Try measuring the distance again. You have now configured the TCP. If the TCP is offset on all 3 axes, like this glue dispenser, it can be difficult to measure the exact position of the TCP. In this case, you can use the robot's TCP position wizard, and the robot can calculate the TCP position. To teach the robot the TCP, start by moving the TCP to a reference point and save this point. Then move the TCP to the same point, but from another direction, and save the point. Repeat from different directions until you have 4 points. The robot can now calculate the TCP position. Let's teach the robot the TCP of the glue dispenser. Start by clicking the TCP position wizard and click Set Point 1. Now, grab the TCP and move it to the reference point. The TCP is at the correct position. Click the Teach pendant icon. Click OK to save this point. Click Set Point 2. Move the TCP to the reference point. The TCP is at the correct position. click the Teach Pendant icon. Click OK. Click Set Point. Grab the TCP and move it to the reference point. The TCP is at the correct position. Click the Teach Pendant icon. Click OK. Click Set Point 4. Move the TCP to the reference point. The TCP is at the correct position. Click the Teach Pendant icon. Click OK to save this point. Then click the Set button. Using the 4 points, the software has now calculated the TCP position, which is inserted in the relevant fields. Sometimes, a tool may be attached at a different angle, meaning that it is not parallel with the z-axis of the tool flange. If this is the case, the robot needs to know the orientation of the tool, which the software can calculate. To do so, position the tool parallel with the z-axis of the base. To teach the robot the tool orientation, start by clicking the TCP Orientation Wizard. Next, click the drop-down menu in the right window. And select Base. Then click the Set Point button. Position the z-axis of the tool parallel with the z-axis of the base. The z-axis of the tool is now parallel with the z-axis of the base. Click OK to use this position. Finally, click the Set button. The software calculates the orientation of the tool and inserts it in the relevant fields. Now you have learned 2 different ways to configure the TCP and how to teach tool orientation. The next step is to configure payload and center of gravity. Remember, payload was defined as the weight of the tool, and the center of gravity is the point on the tool where the weight is distributed evenly on each side. Start by clicking the Payload button in the menu to the left. The software can calculate both the payload and center of gravity. To do so, click the Wizard button. Calculating payload and center of gravity is done similarly to teaching the TCP, by moving the robot into 4 different positions. To move the robot to the first position, click the Next button, and click Set Position. When teaching payload and center of gravity, it's important that you don't touch the tool or tool flange, as this may distort the calculations. Instead, grab the robot by the wrist and move it to the tool outline. The robot is at the correct position. Click the Teach Pendant icon. Click OK to use this position. You have configured the first position and Set Position. Move the robot to the next position. The robot is at the correct position. Click the Teach Pendant icon. Click OK to you have configured position 2 and click Set Position. Move the robot to the next position. The robot is at the correct position. Click the Teach Pendant icon. Click OK to use you have configured position and click Set Position. Move the robot to the next position. The robot is at the correct position. Click OK to use this position. You have configured all 4 positions. Click the Next button. The software uses the 4 positions to calculate the payload and center of gravity. To set as the active payload and center of gravity, click the Set Now button. You can teach multiple payloads and centers of gravity, which you can name for ease of use in the programming. For example, one for the empty gripper and one for the gripper holding a workpiece. You have configured payload and center of gravity. Now that you know how to configure an end effector, let's return to the Pick and Place application. This is where we left off in the previous module. Now, your task is to configure the TCP, payload, and center of gravity for this gripper. You have now configured the TCP, payload, and center of gravity for this end effector. Well done! In the next module, you will learn how to program all the motions and waypoints needed for the pick and place application.